Hey guys, so in this video we want to have a look at how to find the inverse of a 2 by 2 matrix. So there's a couple of things that we need to know firstly, and the first is going to be this determinant. So if you haven't seen the determinant before, I have a video on the determinant. I'd advise you go have a look at this before we do the inverse of a 2 by 2 matrix if you haven't seen this before. So say I'm going to call this matrix, I'll just call it matrix A. I'll say that I have the determinant of A, and the determinant I said was equal to our A multiplied by our D minus our B times C. So we're just going to take this for granted when we're doing this video. So we'll set A times D minus B times C, and I will denote it as this det brackets A. And when I say A, I just refer to this matrix here. So in this video, just assume that these A, B, C, and D, I can use them exactly like they're numbers. They're not actually numbers. I'm just using them to show you guys how our matrix transformation occurs when we have the inverse of a 2 by 2 matrix. So if we have an inverse of a 2 by 2 matrix, what we're going to do is there's kind of two steps involved. So the first is the inverse of a matrix of a 2 by 2 matrix is going to be of the same order of our original matrix. So we said order was this idea of rows multiplied by columns. If you look at this matrix here, it's got 1, 2 rows, and it's got 1, 2 columns. So we say it's a 2 by 2 matrix. Our resulting matrix is of the same order, so it's also 2 by 2, so it's got 1, 2 rows and 1, 2 columns. And the two steps we kind of have when we have the inverse of a 2 by 2 matrix is, firstly, we take our numbers in our matrix and we swap the A and D. So if you have A and D here, in your inverse matrix you're going to have D in the top left hand corner, and then you're going to have A in the bottom right hand corner. So you just swap those two terms. And then the next thing you do after you've swapped those two is you have your B and C. So you leave those in the same spots. So you have B in the top right hand corner, but you make it negative, and you have C in the bottom left hand corner, but you make it negative. So you just make these opposite diagonal terms here, they're going to be negative and stay the same, and then these terms here, A and D, we've actually swapped them and reversed them from our original matrix. So that's our first step. And then what we do is we multiply this entire matrix by 1 divided by the determinant of our first matrix, which we called matrix A. And we call this resulting matrix A to the power of negative 1. So this matrix here is equal to A negative 1, this whole thing. And that just means this A negative 1 just means that we have the inverse matrix. So what we do is we start by we just switch our diagonal terms D and A. We then have we leave our other two terms in the same place and we make them negative, so we have negative B and negative C, and we then multiply it by 1 divided by the determinant of A. So you can see that the first thing that we need to do in order to get this inverse is obviously to work out our determinant. So say we're going to do an example down here now. So we've got 6, 2, 2, and 4, this matrix here. The first thing that we need to do when we're working out our matrix is we're going to work out our determinant of A. So we know that the determinant is A multiplied by D minus B multiplied by C. So our A is going to be 6. We multiply that by our D, so A multiplied by D, A multiplied by D, and then we subtract our B multiplied by C. So our B is 2, and our C is 2. So our determinant, which I'll denote as determinant of A, is equal to 6 times 4, which is 24, minus 2 times 2, which is 4, so our determinant is equal to 20. So we know that everything in this matrix up here is going to be multiplied by 1 divided by 20, or 1 divided by the determinant of A. And then all we have to do now is we just have to do that swapping process that we did before, and then it's just going to look exactly like a matrix multiplication. It's a terrible matrix, I'll redraw that. Well, that's not much better. There we go, that's a little better. Right, so we said what we need to do is we need to swap A and D. So we have A in our top left hand corner, which is 6, and we're going to put that in our bottom right hand corner. And then we have our 4, which is our D, and we put our D in the top left hand corner. So we've swapped our A and D, so 6 and 4 now becomes 4 and 6. Then we said we leave our other two terms exactly where they are, but we just make them negative. So our 2, which is our B, we're going to put it in the matrix, but we're going to make it negative 2. And our C, we're going to put it into our matrix, but we're going to make it negative 2 as well. So C and B are in the same place, but they are negative. So then we've kind of got this matrix, and it just looks like a regular matrix which we've seen many times before, and all we're going to do is multiply it by this scalar constant out the front. So then this just becomes a standard matrix multiplication like we've seen hundreds of times before. So we've got our brackets here. What we're going to do is we multiply everything in the matrix by 1 on 20. So we're going to have 4, and we're going to multiply it by 1 on 20, or divide it by 20. Then we're going to have negative 2, and we're going to multiply it by 1 on 20, or just divide it by 20. Then we're going to have negative 2 down here, so we're going to have negative 2, and then we multiply it by 1 on 20. And then we've got our 6, and that's also going to be multiplied by 1 on 20. So that's what our resulting matrix should look like, and we can simplify that down again. So I'm running out of room here. We can simplify that down again, so we've got 4 on 20 as a fraction is going to be 0.2. Negative 2 on 20 is going to be negative 0.1. So it's the same for both sides, so negative 2 on 20 is also going to be negative 0.1. And then we've got 6 on 20, which is going to be positive 0.3. So I'd say that if we take the inverse of this matrix here, 6, 2, 2, and 4, we're going to get the inverse over here, or I call this A negative 1, is equal to negative 2, positive 0.2, negative 0.1, negative 0.1, and 0.3. And that's the inverse of a 2 by 2 matrix. They take a little bit of time to actually get clear in your head, so if you go through and have a couple of the practice questions that I put up, it should help you to understand them a little more. I hope that's clear for you guys. I'll see you for the next video.